Today I'm going to talk about algae biofuel and why so many scientists see it as one of the most promising renewable energy sources we have. Even though algae are tiny, they grow incredibly fast and naturally produce oils that can be turned into fuel. What makes them especially exciting is that they don't need good farmland and they actually help pull carbon dioxide out of the air while they grow. Algae biofuel is basically fuel made from microscopic algae. These small organisms are packed with natural oils that can be converted into biodiesel or other useful fuels. Algae also grow much faster than traditional plants, so the energy you get from them builds up quickly. Scientists have been studying algae for decades because it can grow in places like deserts, oceans, or wastewater, areas that usually aren't useful for normal agriculture. One common way to grow algae is in open ponds. These are shallow outdoor pools where algae float on the surface and multiply using sunlight. Even though the setup is simple, it's still very effective because the algae have constant access to warm temperatures and natural light. This method is great for producing large amounts of algae at once. Another method is using photobioreactors, which are closed tubes or tanks. These systems give scientists control over everything, including light, nutrients, temperature, and carbon dioxide levels. Because the environment is so controlled, the algae grow faster and stay cleaner than they do in open ponds. This makes photobioreactors ideal for consistent and efficient algae production. To grow well, algae need warmth, sunlight, and a good supply of carbon dioxide. They're extremely flexible and can grow in saltwater, freshwater, and even wastewater. That means they don't take away resources from regular farming. This ability to grow in places where normal crops can't survive is part of what makes algae such an appealing biofuel source. Once the algae are grown, they go through a process to become fuel. First, they're harvested and dried. And then inside each cell are lipids or natural oils. So these oils are removed and then put through a chemical reaction called transesterification, which then turns them into biodiesel. That biodiesel can be used very similarly to regular fuel, making algae a strong candidate for future energy production. Algae aren't just limited to one type of fuel. After the oil is taken out, the leftover sugars can be fermented to produce ethanol or biogas. This means algae can support several renewable fuel pathways at once. That versatility makes algae stand out compared to other biofuel sources that typically only produce a single type of fuel. Right now, algae biofuel is still mostly in the research stage. There are pilot plants in places like the US, Europe, and Asia, but large-scale production isn't common yet because the process is still expensive. Even so, researchers are improving growth systems and lowering costs every year, so the progress is steady. One of the biggest advantages of algae biofuel is that it's carbon neutral or potentially carbon negative. Algae absorb CO2 as they grow, and when the fuel is burned, it releases that same CO2 back into the atmosphere, so you're not adding any new carbon to the atmosphere. This makes algae a much cleaner option compared to fossil fuels. Economically, algae biofuel has a lot of potential. Growing and processing algae can create new jobs in biotechnology, engineering, farming, and renewable energy. On top of that, algae byproducts can be used for things like animal feed, fertilizer, and cosmetics. These extra products help lower the overall cost of producing the fuel. Public awareness is slowly increasing, especially with videos, guides, and research shared by universities and the Department of Energy. Environmental groups also highlight algae as a climate-friendly option. Some airlines, like United Airlines, have even tested jet fuel made from algae. To make algae biofuel more affordable and more widely used, we need to keep improving the technology. Investing more in photobioreactors could help increase growth speed and reduce contamination. Researchers are also working on genetically improving algae strains to produce more oil, and using wastewater as a growing environment could help lower costs while also recycling water. If cost wasn't a barrier, the next steps would be expanding algae production everywhere it makes sense. For example, we could build large algae farms in sunny regions, and then we could connect these farms to power plants so the algae directly capture their CO2 emissions. Wastewater facilities could double as algae farms too, cleaning the water while producing fuel. Working with airlines and trucking companies would help introduce algae-based fuels into the real world. Education programs would then help spread awareness on a national scale. In the end, algae biofuel has huge long-term potential. It grows fast, requires very few resources, and produces multiple types of clean fuel. With continued investment and innovation, algae biofuel could play an important role in creating a cleaner, more sustainable world.